welcome to Zero Exist. This video aims to provide insights into the thought process behind penetration testing and red teaming. I'll be using the CRTA lab from Cyberwarfare Labs. Let's get started. First, we will scan the IP range provided to us, since this is the only information we have. We now see 2 IP addresses being flagged as up. We focus on 80.10, since 80.1 is out of scope based on lab instruction. We can again do a nmap scan, but since this is taking too long for me, I decided to use my own script.
Looks complicated, but it's quite straightforward. In essence, this is a NZ command. Scan top 1000 ports from nmap's port list and also includes port for WinRM, since it's not part of the default top ports. Now we have some result. At this point, we don't have any credentials. If we are not going to rely on CVEs to exploit the machines, then we should target port 22 first. This is because by doing anonymous login, we can quickly determine whether this is an intended path. Seems like we cannot do anonymous login. Then we are left with port 80 for now. Let's determine if the web page is accessible before we decide what we can do with the web page. We can see a login page and a sign-up button. Normally, we can try to figure out common login credentials based on the platform. I tried admin and it didn't work. Since there is a sign-up feature, let's test to see if it is functioning. Because this is a web application, I'll use Burp Suite Community Edition. As with any web penetration testing, we navigate the pages and observe what is available to us and how the web page works. It can be anything from input fields, file upload functions, error pages, directory traversal, how parameters are being passed, etc. To make this easier to follow, I will speed up some parts and explain only the key points. We can intercept request in Burp Suite and forward the intercepted request. When we find a request that looks interesting, we can send it to the repeater for modification and testing. We can see some files being listed. What is shown in the web page? Nothing. If we can do a ls command just like this, we should be able to pull out other files. Okay, we found our first potential entry point. Let's store this new information somewhere. There seems to be something in the comment which could be a password. Let's give it a try. Okay, we successfully logged in via SSH. Sudo as admin successful indicates that this user has sudo ed before. Checking sudo l, we can see that all, meaning we can simply sudo su. Great, now we are root. We can check the IP of this machine. Notice we not only verified what IP this machine is, we also found the internal IP of this machine. There are 3 things we can do now. 1. Scan the internal network. 2. Set up tunneling for pivoting. 3. Search for additional credentials locally. Let's create a bash script to search for internal IP addresses. Okay, we found 3 new IP addresses. Let's try to set up proxy tunneling. To do that, we use Chisel. We can upload it via SCP, since SCP works based on SSH, and we know SSH is open. Ensure we have Chisel in our directory, then run the SCP command. Since we uploaded Chisel using SCP with privileges credentials, we should be able to find our uploaded Chisel in the user's folder. Do a chmod to make sure it can execute. We use Chisel server on our local machine, then Chisel client on the target machine. Once you see the session and connected in both our machine as well as target, we are connected. The main advantage to do this is we can now easily run commands from our machine into the internal network, using the machine running chisel client as a pivot. This is what we call pivoting. We can use proxy chains to test if the tunnel is working. In order to scan the IPs, we can modify our previous query. Make sure we add proxy chains in the front since we are now going through a proxy. We can do the same for the remaining IP addresses. Based on the combination of opened ports like 88, 389, and 636, we can identify there are 2 domain controllers. Before we go back to the third item, which is to find credentials or anything useful in the machine, we can try to do a quick test to see if LDAP search will work without any domain credentials. This is because we want to cover as much anonymous items as possible. Okay, we can't. What about the port 445? We can test for anonymous SMB shares access using NXC. Okay, at least for now, there is nothing we can do for anonymous. Let's go back to the machine then. After trying to find root, txt, looking into different folders, I eventually found the Mozilla Firefox folder, which contained a database file we can view using SQLite 3. We can see a new credential, and this seems to be a domain credentials. As with any credentials we gained, we can test them using NXC. When we see a plus sign and pwned, it means the credentials is valid and have administrative level access on that host. Considering WinRM is open in the machine ending 80.3, we can try to log in to the machine via WinRM using a tool called EvilWinM. Okay, we are in. What we are going to do now is to dump the hashes, since we have administrative access as indicated by NXC. We have more than one method to dump hashes in a remote machine. I prefer to reflectively load Mimikatz so that the entire process stays in memory. To do that, we first download Mimikatz from the official GitHub page. Next, we set up a Python server so that the remote machine can pull the file later. Choose any port you wish. We need to ensure the directory where we run this command contains the file we are hosting, which is the invoke Mimikatz, PS1. We then use IEX, which stands for invoke expression, and IWR, which stands for invoke web request. Specify our IP address, point to the port where our Python server is running, in this case 4444. Then trigger the command in Mimikatz PS1, then add our command for Mimikatz. Okay, since there are no additional defenses such as AMSI, CLM, this works as designed. Alright, now we have the hashes of 98.3. Previously, we can't query AD information since we don't have domain cred, and our LDAP search failed. Now that we have valid AD credentials, let's try to gather Bloodhound data. We can do so by using Bloodhound Python. Okay, data collected. We can simply drag and drop the zip into Bloodhound. Let's take a look at CORPMNGR, which is a new user we found in our hash dump. We can check things like local admin rights, outbound object control, etc. Oh, it can DC sync directly. Okay, this will be quick, I guess. Since it can DC sync directly, let's use secretsdump to dump the hashes in the DC. Oh, before we get carried away, it is always good to check the hash we're planning to use via NXC. A typo. It is always good to check any new credentials we plan to use using NXC. Doing so can ensure if any of our command is not working, it is not due to the credentials. Great, the hash works, against the 80.12 machine no less. While waiting for CRTA to complete, let's look at Bloodhound. If we type the domain in Bloodhound, we realize there is another DC, and there is a parent and child relationship in the same forest. So chances are, after CRTA, we can perform terse attack against the parent domain. I've deliberately left this step until now because everything we've done so far has been IP-based, so hostname resolution wasn't required. As we move into the domain-level attacks, proper name resolution becomes important for authentication and communication with the domain controller, so I'll add it to etc. hosts before continuing. If we encounter error like this, it means our IM packet is in a Python environment, and we need to source it. I lost my secret dump output, so I have to redo it. Now the query is done. Let's get a service ticket. Great, we now see the administrator hash. Now we can access the parent domain. We will still need to use proxy chains. Here, we are in the parent domain as NT system. Thanks for watching.